In this video, we will wrap up our discussion of law of cosines and sines, really more of oblique triangles, with an application for area. Actually doesn't apply to law of sines or cosines, but it is a neat little area formula that could be helpful maybe for you one day. What this formula does is given any triangle, I can find the area of the triangle just given three sides. If you can tell me the three sides of the triangle, how long they are, I can tell you the area of that triangle. I don't need a base. I don't need a height. I don't need anything. So what it is first you're going to plug in, and this is called a semi-perimeter. And it's just you add the three sides up and divide by two. It's not an average, right? Because that'd be three. So you'll have to find S and then you plug it into this formula. Okay, so here's an example. It's real easy. Heron's formula, they find the area of a triangle with sides lengths, and they give us it there. So the first thing, S is equal to over 2, and I just add all three together. And 38. That's pretty bad. 38. Oh, looks not even better. Not better. Let's piece of water. There we go. Cool. All right, not pretty, but it's okay. It'll suffice. All right, so here we go. Bring up my calculator. Bring it to the other side. All right, so I'm gonna add those 29.7 plus 42.3 plus 38.4. Add all those up, divide by 2, and I get 55.2. Now, to find the area, what it is it's the square root of S times S minus A times S minus B times S minus C. All right, so it's the S and then each S with each side subtracted off. Okay, so um, I'm going to do this, I think, all at once. I think that's going to be our better bet. So I'll wait to do the square root until the end, but this allows me to use answer so I don't have to keep typing it in. So now I'm going to do answer minus A, which was 29.7. Close that, open another one, do the answer again. Then I don't have to type that thing in a bunch. 42.3, close, and then the last one, answer. It's going to be uh, minus 38.4, right? So that's just the inside, and then I take the square root of that answer, and I get a 552.3, 552.3 square feet. I put cube, but I meant square. I said it. Oops, struggling here. There we go. Okay, one more, just application, real world problem. So in Chicago, there is a city cross section. I don't even know what you would call that. It's not a sector or anything, but we can look at it like a triangle, even though we have this weird thing up here. We can get a rough estimate for the area if I were just to know all three sides. Well, they gave us all three in the side. You know, they gave us Rush Street, Wabash Street Avenue. I don't know how you say that, Pearson Street. And then they give us the length of each one. And this is how many square meters are available to this developer. Well, we'll just use the formula that we just had. So first I'm going to find S, which is my semi-perimeter. Plug all of that in. 43.5 plus 62.4 plus 34.1 all over 2. Right, so I'm going to pull this out on my calculator. 43.5 plus 62.4 plus 34.1 divided by 2 is going to be a 7, nice and pretty. Cool. All right, so to find the area, we know that we just have to do that. Let's go ahead and just throw it in a square root. Let's see if we can do it all at once. So the answer times the answer minus 43.5. I think it's really just annoying. I just hate typing all this in. 2.4, still not bad though. Answer minus 34.1. And we have them all there, and that gets me a 10,536 point, we'll just do 0.7, right? And this is square meters. So this allows us to find area of a triangle nice and easy without having to do a base and height. This may help you in the future for some of your physics problems. That way you don't have to try to find the base of the triangle and determine a height. You can just get all three sides and plug it in. All right. That is the end of these two sections. The remaining of this chapter, we will go down some like odd and topics here and there, practically just preparing you for future classes with these small ideas. That way you're not blown away by them when you get to it.